Aloha, Rich Alverson here. This is ITS128. And so we're going to continue our lecture on loops, starting with section 5.4 from last time. Let me just share my screen here. All right, so here we are. So we are in, we have just looked at while loops. You remember from the last lecture here. That would be this one here. We finished at section 5.3 in while loops. And then you can check that out to confirm that. Oh, I've got the same background. 5.3. Let's see. All right, I've moved to a different part of the beach. All right, so we're on section 5.4 now, and we're doing while loops, and in this with while loops, we have not covered for loops yet. So with while loops, it's often it's often set up so you're gonna iterate through a certain number of times, and so what you always do when you do that is you have a variable which keeps track of the count. In this case, it's I, and it's going to go n times. So if you set I equal to 1 and it's going to go n times, you can set it up like this. You got to make sure you have this incrementer thing in there, so it'll eventually get to n, and the loop will terminate. A common error is to forget to include the while loop update. That's what they're saying here. Otherwise, then you end up in an infinite loop. Another thing that is common, which they will talk about, I'm sure, is the off by 1 error. You're oftentimes it's you get mixed up, and if this is 0, okay, so if you want to do it n times, you can start with this being 0 and this being less than n, while I is less than n. And then you can also have the I equals I plus 1 at the beginning or at the end of your block, the end of your while loop, like right here. So, and depending on how you use I, you may want it at the beginning, or you may want to leave it at the end. You may want to start with I equals 0 instead of I equals 1. The other thing that I often do, if I can, is I will put the incrementer right up at the top. As soon as I write this, I write this. And then I have all the rest of my code down below. And that way, I make sure not to ever forget the incrementing the loop variable. All right, so anyway, so make sure you understand this. Make sure you understand how to count, how we're counting, and that's where we can get off by 1. Other forms of counting, this counts down. This counts, by 2. And let's see, where's a challenge? There's a challenge in here. Oh yeah, okay. Loops with variables that count. All right, so let's just start this one up. What are we doing? Type the output. Well, n is less than or equal to 5. Print n times 2. Okay, so n is equal to 1, so n times 2 is 2. And then n is equal to 2. So n times 2 is 4. And then n is equal to 3. And n times 2 is 6. And then n is equal to 4. Prints that. Then n is equal to 5, so prints that. And then n is equal to 6, and it doesn't print anything because it stops. All right, let's do a harder one. So you're going to read in a 12, and then you're going to read in a 1, and then you're going to set this variable called step equal to 3. So that means we're going to step 3 at a time, because here we've got this n thing, which is the starting point. It starts here, and each time it starts the starting point, prints it times 12, or prints 12 times 2, which is 24. And then it adds 3 I'm sorry, never mind. Forget that. N is 1. The target is 12. This is 12. So N starts at 1 and it goes 3 at a time up until it hits 12. So the first one is going to be N is 1. N is 1. It's that. 1 times 2 is 2. And then we're going to add 3 to N, which makes it, you know what I'm going to do? I'm going to put up a whiteboard. Let me delete this. A new whiteboard. Sorry, this is taking so long. Okay, so we have here. You can just zoom forward. Okay, there's nobody here today, so while I was doing all that, just skip forward on the YouTube there, right down there. All right, so we're gonna do. Let me get my little. So we're starting out with we've got target equals 12. And we've got N equals 1. So then we print the 2. And then we say N equals plus the step is 3. So 1 plus 3 is 4. Now N is 4. And we come back around and we print 12. No, I'm sorry. We print 4 times, no, N is 4. 4 times 2 is 8. Oops. 4 times 2 is 8. And then N is going to be plus 3 is 7. So then we're going to print 7 times 2 is 14. And then N is going to be equal to 10. It's still not equal to 12, so we're still going here. And 10 times 2 is 20. And then N is going to equal 13. And that is greater than the target of 12. So we're done. So I think this is the answer. Well, well, well. All right, very good. Oh, another challenge. Retype or copy and then run the following code. Note the incorrect behavior. Fix the errors in the code, which should print the number of stars, which should print num stars asterisks. So, the problem is we aren't counting. Okay, we aren't counting. So, num printed is that, and num stars is that, and then we're supposed to have this code. Copy, like starting right here. And we're supposed to, we print, but we don't increment to the count. This is the count. So we have to increment the count because we printed. Num printed equals num, well, we can do it this way. Plus equals 1. So that increments the num printed. So that's all you have to do. That's pretty easy. All right, now we're going to talk about for loops. So for loops are, they aren't as flexible as while loops, but they're more, they're more compact and more direct and all that. More efficient if you can use them, if they're more efficient. You don't have to worry about the loop terminating. That's defined in the in the beginning. And so what it is, a for loop is you have something that's got a bunch of values in it. This is Python. You have something that's got a bunch of elements, and what you're going to do is you're going to go through that list of elements one at a time, picking out each element and each loop. This variable is going to be equal to the element. So it's going to pick off the first one, then the second one, then the third one, and the fourth one. And the first iteration through the loop variable is equal to the first one. Second time it's equal to the second one, and so on. So like you have something like this. You've got a container that's got 3 things in it, and you have so this is the variable name is name. For each name in the list here, print the name. And so this is going to first print Bill, because first it's going to print that one where this is, then it's going to print this one and this one, and so on. Pretty obvious. Okay, so this for all the C's in channel. These are all the channels. This is a dictionary. So you know, this is the name of the dictionary. So the way you refer to an element, the value of an element is by its key. So if this is C is for each C in channels, it's going to go this one, then this one, then this one, then this one, and this one. And this is how you print the key value, because that's what this is. These are keys. And then this is how you print the value of the key. So that's that. All right. So is there a challenge here? All right. So type the program's output. Okay, so we have Tuesday, Wednesday, Friday, and Thursday. And so we're supposed to go for weekday and weekdays, print weekday. So this is the single one. This is the set of them for each single one in the set. In other languages, it's different. And this is the set. And there is an order, so it's Tuesday. For dictionaries, there's not an order, but for lists, there's an order. So the first thing you're going to print is Tuesday. Then I suppose you're going to print Wednesday. Then I suppose you're going to print Friday. And then I suppose you're going to print Thursday. All right, let's do number 4. Colors. Print color in reversed colors. Well, I'm just going to guess, but I would say that in reversed, I would say tan, or maybe it's NATKNIP. No, I'm just kidding. It's tan, pink, gold, and cyan. All right, what's this one? Write an expression to print each price in stock prices. Okay, so we here we go. We're reading in a bunch of stock prices that would look like this, separated with spaces. So this splits. So this reads in the string. This thing will split it into a list of 3, because there's 2 spaces, list of 3. So this is a list. This is that list, 3 of them in there. And what we want to do is print it out. And so we're going to use this variable right there. It already gives us the variable that we're going to call this. That's the singular, the singularity. Price in stock prices. So I think that's it. And see, so you don't have to worry about putting in something that will make the loop terminate, because it's going to terminate because there's a finite number of stock prices. All right, so here's another one. The printing a dictionary. Write a for loop. to print each contact. Okay, so the sample outputs are alf at alf1 plus hmail.com. All right. Oh, I see. All right, well, what does this do anyway? Okay, so we are to print each contact. Oh, I get it. Oh, I get it. So this thing does two things. First of all, it's going to add a name and an email address. And then after that, it's going to print all the names and email addresses. So this adds it. Then we want to print it here. Okay, well, let's see. For contact or cont in contact emails, doesn't matter what you call that. For each one of those, I want to print the value of contact email of cont followed by is depends on what the definition of is, and then I want to print cont. How's that? Yes, so I wonder if that's right. Let's see. You know, I got a problem with this plural thing. So pluralism. You got to put an S here because it's got to be the same as that. Oh, this too. Tell you what, I'm gonna do this. I'm gonna call it. Oh, this is fine. Let's see if this works. All right, so that worked. Okay, now sometimes you just want to go. I want to go from 0 to 4, or I want to go from 0 to 99, or I want to go from 1 to 100, or something like that. And so here's how you do that. You know, the original for loop idea was well, back in Fortran it was a do loop, and you would say do it, and you'd say the variable, and it would go from a starting value to an ending value, and that's all it was. So this is kind of like that, where for the collection part, the collection of elements part, you can just say something like this, range, and that means the collection of integers 0, 1, 2, 3, 4. Okay, if you say range of 3, 7, that's going to mean 3, 4, the collection of numbers 3, 4, 5, 6. If you do the range from 0 to 5, 2 at every other one, that's what the 2 is. Instead of every one, it's every other one. So it starts at 0, then it goes 2, 4. Yeah, see, because it goes by 2s. This is going to go from 5 down to 0. -1 is the incrementer, but it's a decrementer. This is so this is like 0, 5, 1, but the 0 is default and the 1 is default. You know, here 0, 5, 1, same as this. That's what they're showing. Okay, anyway, so that's range. So if you want to do 10 years, here's 10 years. So where's years? Okay, you're reading a number of years and you're going to do this for I in range of years. And if you say 10 years, it's going to go 0 through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it goes from 0 all the way up to the end of the range, or not, but not including the end of the range. Just make sure you understand that. Okay, here's a challenge. For I in range 3. Oh, range 4. 0, 1, 2, 3, but not 4. All right, you can do these. They're easy. Okay, while loops. While versus for loops. Okay, well, you know, there's not anything you can do. Any a while loop is a more general case than a for loop. Of a while loop, of you can make a while loop out of a for loop. You can convert a for loop to a while loop easily. You cannot always easily convert a while loop into a for loop. In fact, you can't. You can't. So if you can do a for loop, then you generally try to. But you have to know the beginning and the ending and before you start the loop. You don't really, but you really should. Okay. Whereas with while loops, you might not know the ending yet. The ending might be coming. You know, you may have a sentinel. You're reading in values, and you may have a sentinel value, which means you know, you're done. That's the end of what you're reading in. So anyway, so that's the difference. Okay, of course you can have nested loops, and that is loops within loops to do some sort of all combinations kind of thing. So this is going to print out all of the 2-letter domain names. It's actually going to have a hyphen too, can't you? And so this thing, you start out with letter 1 equals 0. And why is letter 2 equal to a question mark? You start out with letter. This is the outer loop. A while letter is less than or equal to, so you're going to go, the letters are going to go from A to Z, and the inner loop is also, the letter 2 is going to go from A to Z. So the outer loop is going to start at A, and then the inner loop is going to go A, B, C, D, F, G, all the way up to Z. And then this is how you increment the outer loop, and this right here is the inner loop for letter 2. So you can see how this works. The outer loop just starts A. The outer loop is A for the entire inner loop from A to Z. See, so that's why it's A, B, all the way up to AZ, and then finally the outer loop goes to B, and the inner loop starts over again. So, common thing to do. Or what are we supposed to do? Add numbers. Add a second while loop nested in the outer loop, but following the first inner loop that iterates from 0 to 9. Okay, well, what they're asking us to do is this thing goes from A to Z, but we also want to go from 0 to 9. So I'm going to do this. I'm going to go letter. I'm going to say letter. I'm just going to use the same variable. No, I bet I can just do a number. Num equals 4, 1, for num in range of 10, print f colon letter 1 num. I think this will work. I think that should work. .com. Wonder if this will work. Oh, what am I doing? Print it. Didn't understand that. Yeah, there's 0 all the way up to 9, and then it starts up again. All the way to Z, and then 0 through 9. So anyway, that's how that works. All right, so let's do a challenge activity here. You can watch the recording. I've just been doing challenge activities, so and I'm on 5.8.1, which is we are in we started out with while loops. Let's see. Oh, I think we ended in branching. I think we ended last time in branching, and then we covered these loops. You've probably seen this already anyway. All right, so let's do this challenge here. So we're supposed to print the output, and so we've got an outer loop where I is going for I is going to be 0, 1, 2, and J is going to be 0, 1, 2, 3, and we're supposed to print out. And each time. All right, so it's going to be count starts at 0, and it's going to increment 4 times in the inner loop, and the outer loop is going to go 3 times. So I think the answer is it's either 11 or 12. Let's see if it's 1. Let's see if it's a 1. Okay, I just think it's 12. I want to put 12. Guessing here. Oh, well. The outer loop iterates 3 times, I equals 0, 1, 2. The inner loop iterates 4 times, 0, 1, 2, 3. 0, 1, 2, 3, so 3 times 4. So okay, let's do it. Let's do number 3. The inner loop loops twice. The outer loop while I is less than 1. So the first time it iterates, it is less than 1. And then, so the outer loop is only going to loop once. It's not going to loop. The outer loop is just going to do the inside while part once. The inner loop is twice. So that count is only going to increment twice. So it's going to be 2, he thinks. All right, let's do the hardest one. So the inner loop, it's going to print each time J is incremented. So the outer loop is going to go from, the outer loop is going to start out at 2, and then it's going to be 13, and then that's all. So the first pass, the outer loop is 2. Okay, so the first pass, the outer loop is 2, so the I is going to be 2. So the first time, and J is set equal to 4. So the first time it's going to be 2, 4, 2, 4. And then J is going to be incremented by 3. And so J is equal to 7. 7 is less than or equal to 7. So this will print 2, 7. And then it comes down here because J gets 3 gets added to J again, and so then it equals 10. So this fails, this is false. So it drops down to here, and I is incremented by 11. So now I is equal to 13. And so then we come back around, and the behavior of J is just the same because it's not affected by I at all. So I'm going to put 13, 4, and 13, 7. Yes, and yeah. So let's see if this is right. All right, let's do this one. Given the number of rows and the number of columns, write nested loops to print the triangle. All right. Oh, look, that's cute. Okay, so the outside one is going to be 4. I can call them many things. So I in num rows range num rows, and the inside one is going to be for J in the range of num columns. Now it's either going to be num rows on the outside and num columns on the inside. Well, let's see. Let's just figure it out. So rows and columns. So this is rows and columns. And so 2 and 3, 2 rows, 3 columns. That's right, 2 rows, 3 columns. So this would be 2 rows and 3 columns. Yeah, okay, so is that right? Yes. Okay, let's do this one. I think I'm going to pull up. We really should be writing this code, see what it looks like. All right, just put this over here. What's this one? Given num rows and num columns, print a list of all seats in a theater. Rows are numbered, columns are lettered, yeah, such as 1A and okay. Print a space after each seat. Okay, so 2 and 3 is okay. So there's 3. Is this the same as before? All right. So I'm gonna write the code over here. Copy. And first I'm gonna have to declare more variables. Gee, this looks like it's kind of a hard one. Okay, so I'm gonna do four are in range of num rows. It's my cue. 4 C in range of num calls. Let me just start guessing here. I'm going to say print. No, I'm going to say I'm going to say print. I got to do this F. So I'll do this R. That's the row, followed by, oh, I got to make a C. Okay. Followed by, I'm going to call it an L for letter. Letter. Okay, and I gotta figure out what letters. And so letter is going to be letter is the character of the ord of A, capital A, plus C. So I'm going to take whatever A is, whatever that number is, and I'm going to add either 0 or 1 or 2, however far up this goes, to it to make it, because so if C is 0, then the letter is A. If C is 1, the letter is B. If C is 2, the letter is C. So that's just how I want it. And then this should convert it back to a letter again. This takes the letter, converts it to a number. This adds whatever that value is, and then this converts it back again. And so, is what it's equals. And then this should print that out. I'm going to see what this does. I'm going to add some rows and columns. Too many. Okay, so I'm going to save this. Save as. I'm going to go to my desktop, and is this what this? This is 128, right? Yeah, this is 128, right? Oh, this is 148. Ooh. Oh, this is Thursday. This is Thursday, right? Yeah. Okay. It says Thursday on my watch. Okay, good. We're on the right place. So I'm going to call it whatever, a test py, and I'm going to run it. CMD. Let's bring up a CMD here. CD OneDrive, CD desktop, CD ITS128, PIR is there. It is. Python test.py. Rows, I'm going to say 5 rows, and I'm going to say 10 columns. What is the convert? Is it CHR? Maybe it's CHR. Five, 10. Oh yeah, here we go. Oh, maybe we don't want to start at 0. We're supposed to start at 1. Well, in that case, let's just go. Well, let's do it this way. I'm going to go like this. R plus 1. See if that works. 5, 10. Okay. All right. You know, I'm going to try this. I'm going to see if this works. What does this give me? Okay, I'm going to paste this in there. Copy. Good deal. All right. This is next is going to be 5.9, and there are not any challenges in here. You should go through this. Talks about developing programs incrementally. Means you just start with just a little bit. You start with just a little bit that you know you're going to need. You get that to run, and then once that runs, just a little baby program starting. Just once you get that to run, then you just add stuff a little bit at a time. And each time you add it, then you execute it to make sure that little thing that you added works, that you got it in there correctly. And that's incremental development. And that way, if you ever run your program and it doesn't work, it's only like it only has to do with like the last 3 lines you added, or some small number of lines that you added. So that way, it's not the thing you don't want to do is to type your big program in, just type it all in, and then you run it and it doesn't even work, and you go, what do you do? I mean, how do you even guess? And it's not the error messages, as you know by now, are not always the best. In the old days, when I first started programming, we had punch cards, and so we would type one card was one statement, and so your program was a deck of cards, and and you would submit the job. It's called a job. You submit the deck of cards, and then the computer operators would go back and run the deck of cards, and then the printout would come out, and then you would get your deck of cards and the printout. And in those cases, of course, yes, you wanted to try as hard as you could to type in everything once, and you go over it and over and over in your head, and so that way you minimize the number of submissions. Well, that's exactly the wrong way to program today, because we can do incremental development. We aren't submitting jobs anymore. We're running it as fast as we can, as often as we can. We run it, and we never have to worry about anything breaking. We never have to say, oh, if we put bad code in, it's going to blow up the printer. You can't do that. And so I strongly encourage you. And that's exactly why I don't limit the number of submissions. I don't limit the number of lab submissions. If it takes you 100 lab submissions, then that's just great. Very good, very incremental development. And that's just some anyway. So I encourage incremental development. And in fact, well, I'll show you that later. All right, so 10 is okay. So break and continue. Okay, so now there are ways of jumping out of a loop early. There can be times when you may want to do that. You have a for loop here, and I don't know, this is something where you're figuring out, you want to, what is this? Well, you want to go through these loops until it looks like, in this case, this is something where you go through these loops, and each time something costs money, and so you use that money, and when the money gets to 0, then you're done. Or when the money gets to the meal cost, then you're done. So you don't need to continue any of the loops. And so this is good with for loops, because with for loops, sometimes it's very convenient to say, okay, I'm going to loop through these 100 things, but your code may be such that after like the 50th one or something, you've already found what you needed. And so you don't need to finish the loop, but if you're lazy, you just use the for loop, and it just finished the loop anyway, and it's just wasted computer time. And so you might think that's inefficient, I guess it is. You can stick a break statement in the inside of a for loop, and it'll break out to the next statement outside the for loop. Okay, so here, this is a for loop right here. It goes to here. So you can tell by the indentation. This is the indentation from this is the loop part. It's those two statements. And then but if this break is taken, then it's going to jump out of the loop. No matter how far it's gotten, it's going to jump out of the loop and to the first statement, next after the loop. And this statement here, look, lo and behold, this breaks you out of the most outside loop, breaks you out of there. So, what this is doing is once you've hit your meal cost, then you want to break out of both loops and just pay or whatever you're going to do here. So there's break and there's continue. Break will break out of the loop, and the loop is done no matter how far you got. Continue will just break we'll skip the rest of that iteration and go start the next iteration. Okay, so where is that? Continue, where here you'll go, here you go until this is taken, and this is a continue, so it skips the rest. It skips the rest of the what's in the for loop and goes to the next iteration of the outs. It skips the rest of the current iteration of the for loop and then goes to the next one. So if num empanadas is on 5 and it hits this, then it's going to skip all of this and go right back up and take the next one, which would be 6. It'll do the loop for 6. So continue skips the rest of the current iteration of the loop and goes and starts the next one, and break breaks completely out of the loop and as though the loop is done. All right, let's do this one. Enter the output of break and continue. Okay, so here, type the program's output. Okay, so we read in a 7, and we initialize result equal to 0. Then so we go n from 0 to 9, and what we're going to do is when n, okay, so then n is 0 to 9. What is stop? Well, stop is 7. So when the result becomes greater than 7, we're going to break out of the for loop and print the result. Otherwise, if we don't break out, then we're just going to print n. Okay, so the first time around, 0, n is 0. Our result equals, this is 0 times 2 is 0, plus 0 is 0. It's not greater than stop, so it's going to print 0. And then it's going to come back around again, and n is going to be equal to 1. And result is 1 times 2 is 2. Add that to 2 is 2 greater than 7? No, it's not. So print the 2. And then come back around, and n is now equal to 2. 2 times 2 is 4. So we add 4 onto 2, and that equals 6. It's still not there, so 6 prints. And then we come back around, and n is now equal to, see, 0, 1, 2. N is now equal to 3. 3 times 2 is 6. So we add 6 onto the 6, and we get 12. 12 is greater than 7. So we break out of here, and then we just print the 12. Uh-oh, I'm wrong. We print the 12 here, but back here we're supposed to print n, not results. So the first time n is 0, the second time n is 1, and the third time n is 2. And then when n becomes 3, result ends up being bigger than 7, so then result is printed. Okay, so that's what I think the answer is. Oh, I better do this. Whew, all right, let's do this one. I read in 4, 26, and 23, and I have this result variable. While A is less than B, all right, I better, well, these are pretty tough. Let me pull up this whiteboard. How do I click clear canvas? So I've got A equals 4, B equals 26, and C equals 23. And then I have while A is less than B, so a result equals 0. Well, A is less than B is while while 4 is less than 26, while 4 is less than 26, the result now equals A times 2, so 4 times 2 is 8, and then I'm going to print 8, and is 8 greater than C? No, 8 is not greater than C. C is 23. So no, it's not. So then A is equal to A plus 5. So now A is set equal to A plus 5 is 9. And then I go back around. Is A less than 26? Yes, it is. Is A 9 less than 26? Yes, it is. So a result is equal to equals 9 times 2 is 18. And then I print 18. Wow, it's a tough one. And then is 18 greater than C is 23? No, 18 is not greater than 23. Next time it will be, but it's not this time. So A equals A plus 5. So A was 9. So now A equals 14. Yeah, I went from 4 to 9 to 14. And then is 14 less than B? Yes, it is less than B. So result, do this. I can. Is result that's not right about there. A result is 14 times 2 is 28. And then I'm going to print to 28. And then is 28 greater than C? Yes, it is. 28 is greater than C. So we break out. Oh, and we're done. All right, I think this is the answer. Yes, it is the answer. Well, that's nice. Okay, Simon says, this class goes to 245. Okay, Simon says, in a memory game, Simon says is a memory game where Simon outputs a sequence of 10 characters, and the user must repeat the sequence. Create a for loop that compares each letter of the 2 strings. For each matching character, add 1 point to the user score. Upon a mismatch, end the loop. Okay, sounds like we can have a. All right, so Simon's pattern. Oh, first we input Simon's pattern, then we input the user's pattern. So Simon's, it's 10 characters, huh? Okay, so we know that it's 10 characters. All right. For I in the range of 10. Oh, we have a user score. If Simon pattern of I is equal to user pattern of I, do we make any assumptions about how many characters the user types in? I bet not. If it's equal, then we increment the user score. No. If it's not equal, then we break. Otherwise, we increment the user score. So I bet that's what it is. Let's try it out. I'm going to copy this. Paste it here. And save it, I'll just remember that the first input is the Simon's pattern, and the second input is the user's pattern. I'll just try to remember that. And let's run this. So it's asking me Simon's pattern. So let me paste in Simon's pattern here. There's Simon's pattern. And now I'm going to read in some guy that only has a memory of 4. And oh, look, user score of 4. Well, I think that's probably it. See, the problem is, though, is what happens if okay, so what happens if this is Simon's pattern? Let's run this again. And then let's say that the user enters RRGB, and that's it. Whoa, got an error, out of index out of range error. So you really should have a check. It should be something like in the range of the maximum of the length. Is it len? Yeah, len of Simon pattern, comma the length of user pattern. Okay, not the max, the min. And then the lengths have to be equal too. So, you know, this is a lot more complicated than yeah, right. No, this should still work. Okay, let's see if this works. I'm gonna copy. Oh, I'm just gonna copy this part. Put that here. All right, here. Put this. So let me run this. And the first one. Oh, didn't I length with that? Oh, I forgot I need to do this. I must have something wrong. Length of invalid syntax range. This is. I need one more of these. I think. Okay, first it's doing this. And then what happens if I do RRGB? Okay, yeah, so now it works. Okay, so anyway, so I think that's the right answer, because otherwise you'll get an error. I'm gonna see if this is the right answer. I'm gonna see if it accepts this answer. It should accept this answer. I'm gonna see if it accepts this answer. Oh, am I missing up? I'm missing up. So it does work. Okay, so it accepts that. But does it accept this? Let's see what I originally had, if it accepts what I originally had, which is just putting a 10 here. Does. All right, well, doesn't pay to be fancy, I guess, whatever. It doesn't pay to get it exactly right. It only has to be about right. No, it's not. All right, so else. So this is I've never used this, but so you can add an else clause to a while loop. You can add an else clause to the for loop. Are there any, there is. Here it will be like, if, so the break, does the break, if the else branch, the loop else branch is taken if the loop completes normally. The loop else construct, if the loop completes normally. In the following example, the special message, all names printed, is displayed if the entire list of names is iterated through. So I guess if it's not iterated through, then the break exits the for loop and okay, I'm gonna have to run this because I don't quite see this. Okay, so I'm gonna save this and run it. And if I say 2, then, oh, Janice and Clarice are print, and then it's just done. However, if I say 1, 2, 3, 4, 5, oh, if I say 8, yeah, because there's not even 8. Okay, then once the loop is all done, when it's all done, then it'll also print the else case. But if it breaks out of loop, if the loop doesn't finish because of a break, then that's when it's not going to print the else case. Well, that's pretty clever. Same with the while, I would presume. All right, let's see what. Oh, is there a? Okay, here's a challenge. So, in this one, this is what it prints out. It prints the word done. It prints this. Okay. So this thing, while n is greater than -2, so it's n's. N decrements with each loop. Result increments by 2 each loop. Okay, so n prints out until n becomes n prints out until n is no longer greater than -2, and then at the very end, and then when the loop is done, /result is printed, and then when the thing is all done, done is printed. Wow, this is going to be hard. So I guess you could cheat, yeah, and just cut it. Jeez. No way, man. Let's see. Can I just say really? That's cheating. Okay, well okay. So it looks like you can cheat, but don't cheat. Okay, don't cheat. All right. So result is equal to 0, n is equal to 2. Well, n is greater than, this is the same one. So almost the same. So first we're going to print n. So we're going to loop, always printing n until we're done looping, and then we print /result. So the first time we're going to print 2, and it's going to go down by 1. Result will be equal to, I'm going to make some notes here, I guess. So n is so n is gonna, I'm gonna put n here, and I'm gonna put result here. So the first time n is equal to 2, and 2 is printed. I'll print 2 down here. And then result, once the 2 is printed, result is going to equal to, it was equal to 0, and now it's going to be equal to -4. And then n is going to be equal to 1. And then it comes back around again, and we print 1. And then we result is equal to -4 is -8. And n is equal to 0. And so then we come back around and we print the 0. And result is equal to -12. And n becomes equal to 1. Oh, and then we're done because n is oh, -1. N is no longer greater than -1. It's equal to -1. And result is equal to -12 at the time. So then what prints out is slash -12 and then done. Done. Okay, so let's see if that's right. 2 space 1 space 0 space, yeah, 0 is the last one, slash space -12. Enter, done. Oops, done. Enter. Let's see if that's right. Oh, what? What did I do? That doesn't look right, does it? I think it should. I think it should print. I think it should print a space after the done. Wow, really? Is there an extra space? Oh, maybe there was an. Oh, there was an extra space. Is this the same problem? Yes, it's the same problem. I see. See, I had an extra space like that. Jeez. All right, let's do. These look pretty hard. Let's 1246. Where's how far do we go? 12 is the next. Okay. I'm gonna leave this one. I'm gonna leave this to you. I just want to do the 5.12. There's a challenge in this one, and then we're done doing all the challenges for this chapter. So let's do this one. Getting both index and value when looping. So you can use this enumerate thing. Where's that? Oh, dot index. Okay, here we go. Yeah. Okay. So, this is how you grab an index and a value. So if you're looping through this collection, usually what you would do is you would do, you would do this. Okay, so you'd have origins here, and there's 3 of them in there. So there's a range here. And so, let's say you want to keep track that index 0 is what 4 is, index 1 is what 8 is, and index 2 is what 12 is. So this is how you would do it. You would loop on the index, and then each time you're at a new index, you're able to get the value by doing this, by referencing the indexed element of the origins array. Okay, so that's how you do it. Or you could do it this way, where you loop through the values in origins. You see, this loops through the range. This is the range, loops through the indexes, and then you reference the element by its index. Here, you loop through the elements, in the, you loop through the elements, the values of the elements, and then if you want the index of it, you can use this index method where you put the value, what's the index value of in whatever. So I wonder if you have a problem with that, if you got multiple, two elements of the same. Anyway, and then, or you can use this enumerate function, which you put, or this will return both the index, this will allow you to iterate, getting both the index and the value at the same time. So it it's kind of the combination of both, kind of. And so this makes sure you understand that. Let's do one of them here. Okay, write the program's output. Here's that. Okay, so let's just run this. These are the colors, position. So we're supposed to print position and color all through there. So I guess it's 1, 0 space blue, 1 space black, 2 space green. That's what I would guess. Let's do the next one. I know yours are different. Position number. If number is less than position, print position in X. If number is greater, that's this thing. Okay, so position. Okay, so position is going to be printed. So the first time number is less than 0, so we print a 0 and an X. The next time the number is not less than 0, so we print the 1 and the number. The third time 4 is not less than 0, so we print the index and the number. And the last time number is less than 0, so we print the index and X. All right, well, that finishes the chapters. There's no challenge activity in here. I'll see you next time then.
Okay, have a great weekend.
Yeah, you too, thank you. Take care.